Oh, sorry. Good morning to those of you who are joining us. This is Kim May from the Fillmore Group. We'll be getting started in just a minute. I'm waiting to be joined by Frank Fillmore, who will be presenting with me this morning. We're going to be presenting on IBM data interoperability tools. Good morning to those of you who have joined us. This is Kim May from the Fillmore Group. We're getting ready to get started. I'm waiting for Frank Fillmore, and we will be presenting on IBM data interoperability tools in just a minute. Oh, the presentation's here. Oh, okay, cool. Everyone. For those of you who are joining and who are waiting for us to get started, we are getting the PowerPoint presentation up right now, and not surprisingly, when you're trying to do a webinar, it wants to do an update. Yes, yeah, find that Not Now button.
Are you ready to go, Kim?
I am certainly ready to go, Frank. Thank you for bringing this up.
Okay, sure.
Okay, so
go ahead and start the recording too, please.
It is started. For those of you who are joining us this morning, thank you. I'm Kim May from the Fillmore Group, and I'm being joined by Frank Fillmore. We're going to be presenting this morning on IBM data interoperability tools. And it says on our slide, on our homepage here, that this is for Oracle users. Frank and I put this presentation together because we are doing some outreach this year specifically toward Oracle users for two reasons. One is that, the IBM story is that we would sort of like to be trying to persuade customers to come over to the blue side. And then the other part of this is that the interoperability tools that IBM has work just as well for Oracle as they do for DB2, and we would like to make sure that the Oracle users that are in our audience are aware of this, so that if these are solutions that are a good fit for your organization, you'll consider them. Because as an IBM business partner, we would like you to consider them, we'd like you to adopt them and use them. So next slide, Frank. I would like to introduce, Frank will probably do most of the presenting this morning because one of the things that the Fillmore Group brings to the table is that we are, as an IBM business partner, we pride ourselves on our technical knowledge. Frank is a DB2 Gold consultant and an IBM information champion. He has been running the Fillmore Group for over 25 years. We're a premier IBM business partner. We have a team of about 25 consultants that do work on IBM's behalf, and we work directly for customers. And replication and federation data interoperability solutions are what we specialize in. So next slide, Frank. The services that we provide, the consulting that we provide, basically is around information integration. This is our area of expertise. We've done work with big data and Netezza solutions. We have done some work with Optum data governance tools, which also fall into the information management product family. But the tools that allow you to move data where you need it, when you need it, that's what we specialize in. So next slide. Our agenda for this morning, we're going to be covering basically very quickly IBM's strategy as it relates to Oracle. We want to go through IBM's acquisition path so that everyone understands sort of where this toolbox came from. IBM has been great at developing some things, but they've also been acquiring some specialty tools. And we're going to go through what's in the toolbox, what the products are, and so that you understand what each one does. And then we'll explain a little bit about the purchasing and what you could do for next steps if you're interested in learning more. Next slide. The three takeaways I'd like everyone to get out of this presentation, I want you to understand what these tools actually do. There's no reason in wasting your time, and basically what I'm trying to do is give you a high-level overview of what each tool does and where it would be a good fit, so that you can take a look and you can evaluate this from your organization's standpoint, and you can either say, hey, this would be something we're really interested in, or it's not. The second thing is exactly what the solutions are that are available, because IBM, like many other companies, has products that sometimes when people are selling software solutions to you and you say, I need something that does XYZ, they say, oh yeah, we have something that can do that. I want you to understand which one of these solutions is the best fit for what you need to have done. And then also, of course, what to do next. Frank, I think it would be good to have you go through this since you've actually taken part in the Break Free Forum and you understand a little bit about the history of IBM's relationship with Oracle.
Okay, Kim. First of all, IBM doesn't race sailboats nearly as well as Oracle does. I think everybody at IBM would be willing to concede that. I was wondering if Bob Picciano, when he gives his keynote at the IBM Information on Demand conference in Las Vegas, is going to go up on stage with Christopher Cross's sailing. That would be my choice. But the history has been it's been a hard-fought battle for a long time. Oracle was the first commercially available relational database that was developed by Larry Ellison and his team, building on research that IBM had done for about 10 years in the lab, and he commercialized their product. And they've been going neck and neck across multiple different platforms and operating systems for the past 3 decades. IBM decided in version 9.7 of DB2 for Linux, Unix, Windows to enable the PL/SQL APIs to actually allow customers to port applications relatively painlessly to DB2 from Oracle and be able to use their code pretty much as is without having to change it. So IBM has made a big investment in this space, and so IBM is taking sort of a two-pronged approach. One is I don't think that they think that they're going to wipe the earth of Oracle, but what they're saying to Oracle customers is, we believe we have a better value prop. We believe we can give you software licensing more inexpensively than your Oracle ULA. We believe that we have a better product in terms of feature functionality and performance. If you want to consider that, great, we'll have that discussion. However, if you decide that that is not what you're interested in, if you are committed to the Oracle stack, but you find that there are gaps in that stack that you need assistance with, such as the data interoperability that we're talking about today, then you can do that too. So it's sort of a two-pronged competitive and coexistence strategy. So there are a lot of bullet points here, and I don't want to do a deep dive, but a couple of the things that I mentioned. The IBM touts its soft costs as lower than Oracle, that is the FTE requirements for actually running the database. And I've seen other metrics. It says here that DB2 requires 43% less DBA time. I've seen the number of DBAs per terabyte and things like that. But the bottom line is, I worked with one customer, a large top 50 worldwide financial institution that made a big move to DB2 from Oracle, and their Oracle DBAs were amazed at just how easy it was to do a database backup in DB2 compared to RMAN and Oracle, and the fact that they were able to do that in just a couple of steps with a command. They said, we take a week to do database backups. The other things that I want to tout is the reduced storage cost with the compression, the speed of the database. IBM likes to tout the number of days that they hold various benchmark first places because it's a constant leapfrog. New technology is released and somebody always takes the top spot, but IBM likes to say the number of days for different types of workloads that they've been in the top spot is something that they that they win at. Highest availability, IBM has a lot of great solutions for high availability from hardware to software for DB2, and it's the most scalable. Oracle RAC tops out probably at about 4 nodes, and IBM gets you about 95% scalability at 32 nodes, and that's probably as big as most commercial customers are going to get. So one of the differences between the two approaches to the marketplace is that Oracle has been historically focused on acquiring and building out specialty applications. So Oracle Financials, lots of ERP and CRM solutions. PeopleSoft was an acquisition. So the idea is that they want to do the stuff on the glass. That is the applications that they use, and quite frankly, it's been a very successful strategy. The Fillmore Group is based in the Baltimore area. We do a lot of work in the federal government, and we are constantly running into government agencies that say we are focused on Oracle Financials, pardon me, I lost mine, there we go, Oracle applications, and so therefore we need the Oracle database. So it's a great piece of business lock-in for Oracle. IBM, on the other hand, has said that we're going to try to surround you with the infrastructure and the tools. IBM refers to this as middleware. And so you can see that the investment that IBM has made both in make and buy over the last 3 years, $14 billion in acquisitions and investments, and some very well-known names. So going back a little while, more than 3 years, you can see Essential and FileNet, but also Cognos, SPSS, Netezza, and IBM just made an acquisition the other day now. IBM announced an acquisition, I think, on Tuesday. So they're still going through this strategy, and the idea is that we're going to compete where we can, but we're going to cooperate where we need to, and be able to supply the tool set that you need to your information management infrastructure, because nobody is all one thing. Nobody is all one database, even within the IBM stack. So the takeaways are, Oracle offers a broader range of off-the-shelf application options. IBM offers a broader range of tools, and we're going to focus just on a few of those today. We're not going to try to cover the waterfront in terms of all the things that IBM does, but we are going to talk about the replication and federation technologies, including one that's relatively new with IBM's acquisition of Avisimo. So, Kim, do you want me to keep rolling with this, or did have I?
I think you did a wonderful job, and I think what I'd like to do is explain to the folks that are on right now is that when we're looking at the different information integration tools that IBM has available, there are tools, there are ETL tools, and there are foundation tools, and those are not the tools that we're going to be focused on today. We're actually going to be looking at interoperability tools, tools that help you move data to where you need it when you need it. And so those are the ones in the third box here, the CDC, federation, and replication tools. So next slide.
Sure.
And then also within, this is an IBM slide that is shown over and over and over again. And personally, I think it's confusing as can be, but it does sort of explain the whole information supply chain. And the middle box, the green box that says integrate, that's what we're looking at. That's what we're looking at right now. And again, it's all about moving the data to where you need it when you need it. Next slide. And now we're ready for our first poll. And the first poll question for you folks, and Frank, since you're driving, I think there is a little thing that says polls over there. And let's see if this will work.
So the first one you want, does your organization run more in-house developed applications or commercial off-the-shelf?
Exactly, exactly. I don't know
Got it.
if you can make that come up so people can answer it, but oh, there you go. Okay, perfect. So basically with this, the reason I'm asking is that the toolbox that IBM has put together is really in support of organizations that are building their own applications. And I'm assuming that most people that are on right now probably work for organizations that have a little bit of both, but there's usually a corporate strategy.
And from what I'm seeing, Kim, it's probably two-thirds in-house application development versus one-third off the shelf.
Very good. Okay. So you are the folks that we are, the two-thirds people are probably the folks that are going to be most interested in these tools. However, even people that are running off-the-shelf applications certainly understand that there's going to be moving data from point A to point B, whether to the warehouse or wherever. Okay, well, very good. That's good to know. Okay, so moving on, basically what we're defining as data interoperability is moving data where you need it when you need it. It's pretty simple. And I just wanted to make sure that we were pretty clear about the way that we defined it because I know different organizations define it differently. So next slide. And in terms of data interoperability enablement, there are some different things that you need to do. You need to standardize. And Frank, maybe it's best that you speak to this because I think you work with this every day and you understand how it needs to be done.
Sure. I mean, you know, the form and the fit for function of the data is very important. And this goes from the classic problem of online transaction processing data is not typically formatted in a manner which is effective for people to query it or analyze it. So the idea is that that data needs to be transformed or translated. It could be translated at its most basic level. I'm working with one customer right now who's struggling with EBCDIC on DB2 for ZOS, the encoding scheme used on the IBM mainframe, down to Unicode on Linux. And so basically at a byte-for-byte level, but also transformations at a much higher level, at a domain level, so that we understand the data and that the folks who are working with it aren't seeing a bunch of codes in a field that are meaningless to them, Q's and X's and Y's and Z's in the customer activity code. They actually see meaningful data that says this is a customer that spent $50,000 with us in the last 2 years and has a very high priority in terms of quotes and extension of credit, things like that. But the other thing that's very important is data governance standards and controlling the quality of the data. What we run into a lot with customers is that they will get their answers out of the data warehouse, and the question that the line of business managers, the VP of finance and the VP of marketing will say is, where did this number come from? This doesn't make sense to me. I don't think this is right. And one of the big struggles that a lot of companies have is trying to figure out data provenance. Where did that piece of data come from? What server, what system, what application? And the IBM toolset enables you to do that. It's to trace back the lineage of the data from its initial source all the way through to the slice of the pie chart that you see on the Cognos reports on somebody's iPad. And then finally, the data security policies, and this is crucially important for a variety of reasons, both for compliance and legal reasons, as well as customer satisfaction and customer confidence in your data. We need to make sure that only people with authorized access to the data can access it and access it in the form that they need. So the capability of doing data masking so that the clerk at the grocery store only sees the last 4 digits of your credit card number, or they don't see your PIN and those types of things. But if someone at a high level in management capacity at a bank or financial institution can get access to that same information and maybe need to see the whole credit card number in order to fix a problem. So InfoSphere is the central product set that Kim talked about before that we're going to focus on today. InfoSphere is the family or clan, if you will, of products that IBM both built and acquired There are some products, most of Infosphere is comprised of products that were acquired from other vendors like the Essential products, but there are a lot that are IBM homegrown. There are other pieces, there are other pillars of the IBM information management software product set. One is the basic database management of DB2, Informix, SolidDB, Netezza, and then the Optum family, if you hear that name, is primarily, again, the legacy product set that was acquired from Princeton Softtech, but it also includes some IBM products like the Optum Performance Manager, and they are primarily used for data governance. So things like Guardium, which is used for security policy enforcement for trusted users. That's something that is under the Optum brand family, even though it has nothing to do with either IBM or Princeton Softtech. So the IBM Infosphere replication, IBM fixed a problem that they had, a marketing problem, not a technical problem, in that they had acquired Data Mirror 5 or 6 years ago now, which does change data capture. That is, changes that appear in a database recovery log, whether it's SQL Server or DB2 or Oracle, and then replicating those changes to someplace else. The whole movement around change data capture was initiated by SQL Server or Sybase. It's getting fuzzy now, but one of those vendors, primarily Sybase and their replication server, 15 years ago, and the realization was that there were a lot of customers who were taking full volume extracts of their database from their transaction processing systems each night and FTPing that to a reporting server. And only a small percentage of the data might have changed from day to day, but they really didn't have a good way of identifying what the changed data was. And so they were spending, hours and hours of processing time and gigabytes of storage and lots of CPU cycles in order to move a whole lot of data that hadn't changed from day to day. And somebody finally said, this is a really bad idea, and it's very expensive, and with terabytes of data, with the explosion in data volumes, it's just not practical anymore. We can't fit all this into our batch window at night. So what a lot of vendors have done, IBM included, is that they have built solutions to look at the recovery logs where you do have a record of the changed data, the inserts, updates, and deletes that have occurred throughout the day. And then by using that log, you gain a couple of advantages. Number one, you're not invasive in the source database. You're not doing a read of hundreds of millions or billions of records and tying up database resources. You're looking at the log after the data's come out and been committed to the database, and you're only dealing with the deltas. So I mentioned number two first. Number one is the IBM Q Replication product. It is built on IBM's heritage product. It's known as the Data Propagator Relational and grew up to be known as SQL Replication. That technology has been around probably for close to 25 years now. But IBM saw a need in the mid-2000s, and I think we're going to see this on the next slide, or the slide after that. But the idea was that given the low latency requirements, the need for speed to be able to get the data from one place to the other, that the technology that IBM was using in SQL replication of staging tables just didn't scale. And so they swapped out the staging tables that sat in the middle for MQQs, which give you assured ordered delivery of the data in the sequence you need. And the Construction Bank of China is now deploying this on a scale that is just unimaginable to me. This is a bank that has 300 million customers with levels of transaction volume processing that are just way beyond anything that we're seeing here in North America, at least for commercial banking. And they're using this technology in order to manage their high availability and their distribution of processing resources. So let me rein it back in for a second because I've gone a little off-road. Why do we want to implement replication? Well, I've mentioned a couple of the reasons. To load a data warehouse, for example. But we also do it for disaster site recovery in order to have a hot site someplace else, a active, inactive failover scenario, so that if one server is taken out of service for either a planned or unplanned outage, that we have someplace else to go to that has up to the last successfully committed transaction. Load balancing, so the ability to distribute a workload. We have a customer constant contact, the email marketer, that uses IBM's Q replication technology so that you can go to a variety of different servers in order to ensure that their business is 24 by 7 by 365, and they have a worldwide customer base in the hundreds of thousands. So they can't take an outage. They can't say Sunday morning at 3 a.m. we're gonna take this offline to do maintenance because they're somewhere in the world. It's not 3 a.m. on Sunday morning. It's 2 in the afternoon, and some small business person is trying to get an email mailing out. And you want to integrate data from disparate systems. You want to try to collect data from maybe a variety of legacy systems, maybe IBM mainframes with DB2 for custom-built applications, where you have your logistics, as well as financial systems and maybe a packaged application, and you need to meld this data together from a variety of disparate sources. So the definition of replication is the process of copying a portion of a database from one environment to another and keeping those different copies in sync on some SLA basis, service level agreement that says these databases will be in sync within 1 second of each other. So if a change occurs on one database within 1 second, that change will appear and be committed on the other. So I've mentioned all three of these products in passing. So the SQL replication started as a data propagator relational. It is still around and available at no charge. If you own DB2 for Linux, Unix, Windows, you have embedded in that product the capability to do the SQL replication. Q replication was released in 2005, so almost 8 years ago, and basically, as I said, swapped out the staging tables used by SQL replication as the transport mechanism for MQ, and that solved a lot of problems in terms of reliability, availability, lower latency, better performance. And then the data mirror ICDC. Now, IBM acquired this product because ICDC, what IBM now calls InfoSphere Change Data Capture, had a much broader variety of heterogeneous data sources and targets. So whereas Q replication was focused primarily on DB2 with a smattering of Oracle, if I had SQL Server or Sybase or Informix or a variety of other products, data server products, then I could merge all those together. The ability to choose which is best for you, Kim is an expert in this area. She actually developed a presentation for the IBM Information on Demand conference coming up here in a month or so, which actually was an hour-long presentation just on how to answer this question, how to determine which replication technology is the best. So I'm gonna toss it back to you, Kim.
Okay, sure. And I think one of the things that I want to make sure the folks listening in understand is that the reason, when IBM did the data mirror acquisition, they did end up with two different products that basically are designed to do the same thing. However, we all know in the technical world, there's so many different flavors and different nuances. And so the reason that for the data mirror acquisition was, as Frank said, all the different sources and target databases that were supported. And I think that's one of the that's definitely the strength of ICDC. One of the things we will touch on very briefly in this presentation, because I know that some of my IBM colleagues are joining us today, is that IBM will be making a major announcement at their Information on Demand conference in Las Vegas at the beginning of November related to the merging of these two products. And that's about all I think I'm allowed to say at this point. But what you're seeing right here is that, I hope, is that IBM has a heritage of supporting, of being a technology leader in terms of replication solutions, and definitely making sure that they react to what the market is demanding. So originally, as a DB2 provider, it was DB2 to DB2 homogeneous replication, pretty simple, pretty straightforward. As people wanted to get a little more complicated and wanted to bring different databases, data from different databases together, that was the rationale behind the acquisition of Data Mirror. And now we are all seeing interoperability, again, that word, that we want to be able to take whatever is in data source A and put it with data source B. When I need something out of A and B at the same time, I want to be able to get them. And that's basically what some of the replication is designed to do. So I think, Frank, if you go to the next slide, I think I included a couple slides with some of the terminology that people use around replication. I think the most important thing that people are two are probably here that are most important. One is latency, one is speed. If you have SLAs in your organization and you need to move, if you have a failover scenario, if database A goes down and you need to move over to database B, how quickly do you need to have those in sync? And people talk these days, it used to be 5 minutes, 10 minutes, half a day. Now people are talking sub-second. And that's important to understand within your organization. If you're loading up a data warehouse or a data mart that somebody wants to have available to run reports on an on-demand basis, maybe it doesn't need to be that fast. But if you're looking for something where you've got a production system that needs to be available 100% of the time, you're going to have a totally different SLA. The second thing that people need to be looking at when they're looking at replication is whether you're doing unidirectional, bidirectional, or peer-to-peer. So you want to look at, am I moving from point A to point B to point A, back again, A, B, and C? The complexity, it gets very complicated very quickly because you can have some contention that you're going to have to work out, and you're going to have a lot of different, the architecture can change, and that can affect everything else that's involved here. So it's just stuff to keep in mind. Frank, I think the next slide has some other terminology. We're going to make this slide deck available. We'll put it up on our blog either this afternoon or tomorrow, so you can certainly go through this at your own pace if you're interested in replication and really want to understand what the factors are that you need to be evaluating. So what we have here basically is just a list of all the different terms and terminology and some of the factors that you need to consider as you're going through. And one of the things just to mention here, IBM did, I think 2 years ago, they put the cost of both of the replication solutions, they set the cost at the same amount. And the reason for that is that they really didn't want people trying to decide, well, maybe we can make this one fit. It may not be the right solution, but we want to make it fit because it's $2 cheaper. Don't do that. Don't do that. Never do that. So that's what that is for. And Frank, can you explain some of the Q replication technical aspects?
Sure. So once we're familiar with the terminology, the sources and targets, where the data is coming from, primarily the log of a relational database and where it's going to, either another database or some other form. Q replication supports as sources DB2 for ZOS and LUW. If there are any System I people on the phone, the old AS400, that is not supported for Q replication, and no plans to do that I'm aware of. And then the targets are DB2 for ZOS and LUW, along with Oracle, Sybase, and others with federation. So I can retrieve data that's being generated via inserts, updates, and deletes on either DB2 for ZOS and LUW and Oracle, and then the deltas that are being produced can be applied to any of the databases that you see there. In addition, I have some other choices. I could actually have that data not produced as an insert, update, delete on a target database. I could have that be the input parameters to a stored procedure. So I may have some complex business logic that needs to occur. I may also want to produce an XML document. So I may want to invoke, let's say I have a legacy system where I have DB2 for ZOS, which handled my manufacturing or logistics, and based on what we've built, we need to update the general ledger, and the general ledger is written in is an Oracle application, and I don't want to do an insert, update, or delete into Oracle Financials. What I want to do is I want to pass it a transaction which says update the general ledger and have the business logic of that application work. So this is a great integration technology of being able to move data from disparate systems, but have them almost in an SOA type environment, be able to apply those changes in a way that makes sense on a real-time basis. So the Q replication is probably about 3 times faster than SQL replication. It is a resiliency technology that works along with IBM's high availability disaster recovery. It provides an active-active solution. HADR is primarily an active-inactive or active standby solution, meaning that I only have access to my data on one server. HADR covers a broader range of database events, such as utilities running and things like that, or the generation of DEL. If I create a new table, that's not something that would be covered by queue replication, but it would be by HADR. Don't want to go too far off-road because this is not an HADR pitch, but this is a great way to keep two servers active simultaneously so that I could operate both of them, either one as transaction processing and the other as a reporting server, or to have both of them handle transaction processing for load balancing. And then finally, queue replication has a built-in scripting language called ASN-CLP for command line processor. And the value there is that I can develop all of the artifacts that provide the configuration of the replication environment, the mapping between the source and target tables, the transformations that I want to occur, the filtering that I want to occur, can all be done in a scripted language so that I can move easily from a development environment to performance environment to UAT to production, and basically be able to use the same artifacts that have been tested. So ASN-CLP would be very analogous to the data definition language statements that we use to create tables and indexes, but in this case I'm creating subscriptions. So the InfoSphere change data capture supports DB2 on all platforms, including the System I. Its heritage is actually on the AS400. As well as Oracle SQL Server and Formix, etc. The targets are all those databases as well, and even non-relational targets. So I could deliver via InfoSphere change data capture data to a data stage job or to an MQQ. So I could develop, again, sort of a service-oriented architecture, SOA type environment where I have real-time events occurring and I trigger processes on different systems, so I could use this technology to enable that. Both unidirectional and bidirectional replication are supported, so I could build in load balancing for ICDC environment as well. The latency, we believe, IBM, fortunately or unfortunately, never gets into a bake-off against itself. If somebody on the phone would be willing to fund a benchmark between QRep and ICDC, we'd be happy to execute it for you. But that is not a critter currently in captivity, I don't believe. But we believe that the performance is going to be better in queue replication based on some architectural and scalability issues. Now, probably get into an argument if there are any ICDC people around, but the bottom line is we don't have the facts to support either contention, so we just don't know. And then finally, the ease of use. There is a great GUI interface called the Management Console that is used for administering the ICDC environment. IBM has just released the CHC CLP, which is analogous to the scripting language in ASN CLP. And the question that might arise in your mind is, why didn't they just extend ASN CLP to InfoSphere change data capture? And you would, my answer to that would be just sort of scratching my head, wondering the same thing. It is what it is. But the bottom line is one of the differentiators between the two technologies. One of the gaps in ICDC has been closed with the CHC CLP language. So Kim mentioned the pricing before. The bundle of all of these products is called IBM InfoSphere Data Replication, or IIDR. And when you purchase that, you are purchasing the right to install any one of those products that we have discussed in detail: SQL replication, queue replication, or ICDC. So the good news is you can make an informed decision, irrespective of price, as to the best product for a particular use case in your environment. And you can do this. You can say, we need to replicate. We know we need to do this. We know IIDR is going to cover the functionality. One implementation may be better than another, and we can determine that once we have completed the business requirements and the technical requirements and the design, and decide what to implement at that point. So we are IBM, by combining the products into a single bundle, IIDR, have taken what used to be a sales decision or an acquisition decision and moved that to a implementation decision. And just a little bit more detail here. The 173 per PBU that you see there is processor value unit. This is how IBM prices distributed software based on the processing capacity of the server on which the software is going to run. And this, again, describing PBUs is probably a whole nother hour-long discussion. The bottom line is that if you have any questions about what you need and how much it's going to cost, you can contact Kim for more information.
Yeah, and I think one of the things we'd also like to make sure everyone's aware of is that, IBM is a technology competitor. And if you're taking a look at a replication solution, the price per PVU, when IBM is pricing a replication solution, they're going to be looking at the servers where all the data sources, where the data is coming from, and all the targets are. And so one of the things that they will be doing, they will be adding up all those PVUs and then multiplying it by 173 and then coming up with the price. However, two things to keep in mind. One is that because IBM is very competitive about their pricing, there is a thing called a special bid where you can go in and you can say, hey, this is the price that you need to get to beat the competition. And IBM is usually pretty good about being an aggressive competitor. The second thing always IBM customers or IBM potential customers should always remember is that, like so many other firms, IBM is very focused on their annual sales number, and their sales year runs along with the calendar year. So the closer you get to the end of the year, it's just like buying a car, the better the prices get. So we're in the fourth quarter. IBMers are real aggressive with pricing. So our second poll question is, what factors would your organization evaluate to determine the best replication solution? Everyone has different criteria, and it's really important when you're starting to look at a solution like this to know what you need, to know what's going to make your management team happy and make your solution work.
So, Kim, we're seeing most people, 3/4 by a wide margin, say that all of the above, speed, latency, cost, and the supported data sources and targets are all going to be integral data points in making the determination as to which product to use.
Well, and I think that's really good, and I think that also it's good because it also validates IBM's strategy. IBM really is doing all of the above. So that's the section on replication, and now we're going to move into the federation solutions. And IBM has two federation solutions. One's a homegrown product called IBM InfoSphere Federation Server that IBM developed many years ago. My personal story with InfoSphere Federation Server is that when I first started talking to Frank, and I had approached Frank about coming to work for the education side of the Fillmore group, he was explaining to me about what Federation Server did, and this was about 10 years ago, and I was like, wow, that is just the coolest thing in the world. And it has always amazed me that it didn't really, as a product, it's the ability to combine data from different sources. I mean, what could be better? IBM also, just in the past year, went out and purchased a company called Vivissimo, and they have renamed Vivissimo, or Vivissimo, I think because nobody can say it. The product name is Vivissimo Velocity. They have named it InfoSphere Data Explorer, which is a little easier to say but not as exciting. And it does federation as well. So Frank, I'm going to turn it over to you to explain how the solutions work.
Sure. So InfoSphere Federation Server. So if we were all in one place, I would offer a beer to anybody who could name all of the AKAs that InfoSphere Federation Server were known by, because it's a product that started its life out as something called Data Joiner back in the early 1990s, and I won't bore you with all the iterations since then. And I think it's one of the reasons that the product has really suffered is that people don't know what it is and might have heard of it or know it by a different name and wonder where it went, and so it's sort of suffered from that regard. But the bottom line is it is, as Kim said, a very cool product. It involves some IBM technology, an IBM vice president, a guy named Nelson Matos, who had helped develop the underlying technology for Federation. IBM Silicon Valley Lab is now the vice president for engineering for Google Europe. So really smart people worked on this, and they put together a great product. And the idea is we call it data virtualization. In an environment today, we may have the requirement for data from multiple different data sources, heterogeneous sources, real time. So whereas data replication takes data from one place and moves it to another, Federation leaves the data where it is in a transaction processing system or in a reporting environment or some other type of data store for whatever you're using it for, and allows you real-time using an SQL API to be able to go and get that data and retrieve it and gather some intelligence based on it. So the type of thing that I think about is a distributed environment like a logistics company, an Amazon, that has their transaction processing occurring in their e-commerce site, Amazon.com, but needs to interface with logistics sites and warehouses and shipping and UPS. And I'm sure that they have a great SOA environment. I'd love to see the diagram of their enterprise bus. But the bottom line is that would be a case where I may want to pull data from widely disparate different data sources stored in different databases, in different servers, from different vendors in widely disparate geographic places, and be able to take a snapshot of what's going on at that one time. Or an airline. There are other examples where airlines are not only dealing with their own internal systems, but also their vendors which supply food and beverage for the airplanes and fueling and things like that. So again, I want to know near real time what's happening in all these different systems, and I could use Federation as a product that would enable me to do that. So Federation integrates and transforms data and content to deliver accurate, consistent, timely information from a single platform unified by a common metadata layer. So the idea is that you don't need to know, as an application developer or as an end user, the underlying complexity of what all these systems are. You are coding to a single intermediate metadata platform that goes out and gets all the data for you. So it's sort of like when you pick up the telephone and you dial a telephone number. You don't know all of the towers and landlines and satellites your call is bouncing off of. All you need to know is the telephone number that you want to call, and that is routed behind the scenes without your knowledge through a variety of a dynamic network to be able to get it to the proper location in order to get your call completed. And that's sort of the way that Federation works, is that it handles dynamically all of the back-end processes necessary to go and grab your data. So, as I've sort of described here, no matter where it resides, what format it's in, the vendor of the data store, without creating any new databases or disrupting existing databases. So I don't need to do periodic extracts. I don't need to pull the data out of a database and put it into a data warehouse and combine it. All of this is being done real time where the data resides today without having to make a copy of it. Uses standard SQL as the API, even for non-relational back-end data stores. So I could have something like a life science data store, pardon me, or I could have numerical processing from the factory floor. I could have a variety of different non-relational databases. I could have a spreadsheet. I could have Microsoft Access. I could pull this data. One of the use cases that I saw for Federation early on is that a lot of companies use things like spreadsheets and Microsoft Access as business critical applications. They manage and monitor departmental work that, if it were lost, would seriously impact the business. I worked with a federal government agency which issued grants, and they had a number of these different systems that basically resided on somebody's laptop that were never backed up. They were never managed in any way. Federation would be a way to go out to these systems and on a periodic basis be able to grab this data and move it to a central repository just as a snapshot or a checkpoint, so that if somebody's hard drive goes up, we don't lose a lot of business critical information. So you can see a list of all of the different types of sources and targets, and basically with the extensibility of the InfoSphere Federation server, we could probably get to anything that's stored on disk. Anything that is in digital or electronic form, we could get access to.
Yeah, and Frank, I can't remember exactly what it was, but I saw recently there was a release about some updated information about InfoSphere Federation server with some added data sources, and it was kind of funny because it was kind of like, okay, well, I think they can pretty much get to anything. It is kind of silly to be announcing something new,
but sometimes you need something to announce.
Oh, exactly.
So,
actually, now that I'm looking at it, I think they were announcing that they could do more things with Teradata than they could do in the past. You can see Teradata is already on this list, so it is kind of it's going a little above and beyond.
Yeah, but as you can see on the right-hand side, you can there are software developer kits, web services can be accessed, Excel spreadsheets, flat files, sequential files. Yep. I worked on a POC for a customer that had sequential data sets, and they wanted to be able to access that data via an SQL API, and you can do that. Or You can extend to legacy systems like IBM IMS. So it is pretty broad-based. So some of the features, some of the things that distinguish it, the transparency, as I mentioned before. You don't need to know the underlying complexity of where all the data is stored. You are either writing queries against or coding to a single API. And so this gives your company, your enterprise, a great deal of flexibility to move from data server to data server, because once you code to this API, you could pull a server out, you could move from, let's say, IBM's content management backend and move to FileNet, and if you were using this layer of indirection of Infosphere Federation server, your applications wouldn't be impacted at all, because that agent that goes out from the Infosphere Federation server and gets your data is the only thing that would need to change. Everything on the front end would remain the same. So it is heterogeneous. We mentioned that it is extensible. There is a technology called a wrapper, which allows you to build your own data sources and targets if you need to. High function, so I could do full query processing against all data sets. It actually maps the functionality in the DB2 API to the equivalent functionality in other servers, and actually allows you to get functionality in those servers that might not be available otherwise. IBM has made the claim for many years, and again, this is not anything that I've seen run in a benchmark, that because IBM's optimizer technology is so superior, you can actually run faster against Oracle data sources using Infosphere Federation server than you can natively against Oracle using their own client software. So the Federation server approach, the user's client sends a request. This could be a simple query, or it could be an application that is encoded using a DB2 API. It goes from the little monitor there to, number one, the federated database server. So you're accessing all your data. All you need to know about from your application is the federated database server. Federation server parses the request, and then it says, I know where this data is, and this data is, and this data is. So I may have a query that is something like, select something, something, something from Oracle.financials, comma, db2.logistics, comma, SQL Server.personnel. So that I have three different tables in three different data sources on three different platforms. So the federated database server would say, I know where that is, and go out and get it. So it's going to send the query to each of the back-end systems, as you can see there in number 3, to be able to pull that back from all of the different data sources that are available. Each source system, each of the repositories of information is going to receive its query fragment. It's going to process it, and then send back whatever the result set is of its particular application. The Federation server assembles the final result. It may require some additional processing, such as sorting, aggregating, joining, and then that result is sent back to the client in number 1. So the metadata, which enables us to manage this system, there are a series of entries that are made into DB2 catalog tables, which reside on the Federation server in number 1. The box that we see there, the federated database server. So there we identify the back-end servers, things like the IP address or host name, the port number, how I get access to the database, even down to the version level. So it's very important when I'm building these mappings that I identify the version level of the back-end database, because the Federation server is smart enough to exploit the underlying database's functionality at that version. So I'm going to get different different processing if I have Oracle 10 versus 11GR2. The second thing is the user mappings. As you can imagine, looking at the diagram again, I could have multiple back-end data servers. What I don't want to have to do as a database administrator or system administrator is to keep Janie's user ID and passwords in sync on all those back-end systems. It may just well not be impossible. I may be using LDAP on some. I may be using distributed computing environment token passing on another. It could just be the Wild West out there in terms of user IDs and passwords. So in the metadata, in the Federation server, I can do the user mapping so that when Janie logs on, she has a valid user ID and password for each of those systems. All of the security is enforced at those systems the way that they ordinarily would be. So if Janie on DB2 for ZOS translates into Jane Smith. J Smith is her user ID. Then Janie's user ID, J Smith, will have been granted privileges to tables for retrieval in the DB2 for ZOS server, and she will only have access to that data to which the J Smith user ID is entitled. She won't have any extra. So this is not a bypass or a backdoor. We are not restricting or opening access beyond what is already available. The user IDs and passwords are encrypted so that it's not a point of security breach. And then the server options define the characteristics of the data source. So I may be mixing EBCDIC data on a DB2 for ZOS to a DB2 for LUW or Oracle or SQL Server, which are encoded in ASCII or Unicode. And so I need to determine things like sort strings, the collating sequence, and how that is being processed. And I have the ability to affect that and say I want it to appear the same way it would in EBCDIC, or I want it all to be merged down to Unicode. So finally, the metadata, and I don't want to spend too much more time on this. I'm looking at the clock, and we need to wrap up in a little bit, and we still have a couple of things to go, is the nickname. So the nickname is what I actually encode in my SQL statement, which points me to the back-end database server table that I'm going to be accessing. So a nickname is like an alias for a table, and it basically takes into account the server, which we've defined, and where that table and its schema can be found so that we can access that. And the database actually includes statistical information. It gathers statistics, as most databases do, so I know how many records are in an Oracle table or how many different column values will be found in a SQL Server column, so the optimizer can make informed decision and actually make the best choice as to how to go after this data in the back-end data store. So I'm going to skip over this slide. I've talked about security and the Federation server pricing. So again, I'm going to toss it over to you, Kim.
Okay, and the Federation server pricing is based on pricing the sources, the different data sources that you'll be using and the processors that are inside the servers on which those data sources exist. One thing that is, for you Oracle users out there, one thing that is good to know is that if you decide to move some of your workloads from Oracle to DB2, IBM has an offering. One of their product bundles for DB2 is called DB2 Advanced Enterprise Server Edition, or AESE. The AESE bundle includes a limited use license of Federation Server that allows you to federate Oracle data and DB2 data at no charge, no additional charge. So one of the challenges with using any sort of Federation product today is that they're very technical solutions, and they tend to be rather expensive. So it's just something to keep in mind if you're looking at a way to actually federate data as inexpensively as possible. Not that cost should always be the issue, but it is sometimes, so it's something to consider. So
Great point, Kim. Thank you.
I think we'll go through. I think the next slide is a poll. Oh, actually, the next slide is moving right into Infosphere Data Explorer, which I would like to do. So, in fact, yeah, I'll go ahead and get this started, Frank. Infosphere Data Explorer is the Vivissimo acquisition that IBM made a couple years ago. Vivissimo is very the Vivissimo tool, the Vivissimo Velocity tool, is a Federation solution that was designed for big data solutions. It's more designed for going through just gigabytes and gigabytes of data, as opposed to Federation Server, where you could be using it for something as simple as an Excel spreadsheet and DB2. The three computer science researchers at Carnegie Mellon that developed it were big Hadoop users. They understood the direction that the world was taking with big data, and I think that this was something they took. What was a concept and was, IBM had a solution, other firms had solutions, and they designed their own tool so that they could use it primarily for these big data solutions. There are, as you can see, all different sorts of data repositories within organizations, and one of the things that they did with Vivissimo that was considered state of the art at the time was that their direction was to go after the federation of unstructured data as opposed to structured data. Tools like Infosphere Federation Server were designed at a time when most of the data that we're using has been structured data. It's in databases. And so now we're seeing, with the explosion of the internet, we're seeing so much more unstructured data that the ability to combine unstructured data has become really important. And Frank, I'm going to let you get into this a little bit more from the technical side, because you understand this a heck of a lot better than I do.
Sure. So the architecture is not dissimilar to the Federation server that we saw before. There are user profiles and an application framework that goes to a back-end search engine. The search engine has access to a variety of different back-end repositories, and there is what they call a connector framework. And so this is similar to the wrappers and the servers that we talked about in Federation Server, the ability to go back to something specific. So you can see RDBMS, RSS feeds, email, web, content management, CRM and ERP systems or file systems, pulling all that data together, allowing you to do text analytics, which are built in. So when I do my searching, I know that Bob and Robert may be the same person, so I can pull that back. So if I get Twitter feeds or things like that, or Facebook page analysis or sentiment analysis, I can do that type of text analytics support, and then be able to pull all this data together and be able to drive it through applications, which could be used for a variety of different purposes. So real-time analysis for e-commerce, or the ability to try to place display ads in websites. So the idea is that we want to be able to take advantage of data that's that is real time and basically unstructured and unplanned for. The example that I've used before, being a nice Catholic boy, is the resignation of Pope Benedict that occurred a few months ago, and this was a black swan. This was an unexpected event. Nobody had resigned the papacy in the last 600 years. But the question that I ask my customers all the time, do you see that as a business opportunity? And a lot of people shrug their shoulders and say, how do you make money from that? And so my take on it was, if I were a travel agency and I was able to do sentiment analysis and follow Twitter feeds and Facebook pages, and I was able to determine that people were commenting on the fact that the Pope had resigned and a new Pope was going to be elected, what I would want to do is get an email out to all of these people offering them a vacation excursion to Rome so that they could witness these historic events. And if I was the first there, I may be able to develop some business that wouldn't be there otherwise. So this is an example of being able to respond nearly instantaneously to unexpected events, and that's the type of thing that a product like Vivisimo would allow me to do through the news feeds and Twitter feeds, combining that with internal data, pricing, airline seat availability, hotel reservations, and all those types of things.
Yeah, and I think one of the things that's interesting when you're trying to compare and contrast products like Infosphere Federation Server and Data Explorer is that Data Explorer was designed to be looking at gigabytes of streaming data. It's designed to do that sort of, to be federating something that's moving quickly and where there's an incredible volume of data. Whereas Federation Server is really looking at things that are on a different sort of scale and definitely more structured data.
So you're talking about the velocity aspect of big data, which is something that Vivisimo does very well. The Federation Server really doesn't view data in terms of velocity. It basically looks at data at rest.
Exactly.
Okay.
Yes, and I think it's one of the things when you look at these products and you say they both federate. Federating is combining data at its most simplistic. The reason that IBM made this acquisition was that they realized, IBM has now introduced their own portfolio of big data solutions. IBM wants to be a thought leader with big data. We understand it's a totally new concept and technology, but it's really important, and it's going to change the way that we do business. One of the things that I tried to define here in this particular slide was to give people a sense of the Data Explorer pricing. Because Data Explorer is used for such huge quantities of data, I actually have, IBM is using a different metric for pricing called the resource value unit. And I actually had someone after I'd put the slide deck together this morning, somebody gave me an easier to understand metric, which is basically the cost is about $2,000 per gigabyte of data that you're going to be federating, or the data source that you're going to be looking at, that you will be using, that you'll be federating data out of, if that makes sense.
So this is a different metric than the processor capacity of the server on which the product is installed. It's actually looking at the volume of data to be processed.
Exactly, because if you're looking at streaming data or you're looking at big data, your metrics are going to be totally different, and you're probably going to have the volumes of data are going to be completely different, and you may not be hosting that. You may be taking data that's out in the cloud or taking data that's public data, and you're going to be federating some of that public data. And so basically what IBM wants to be able to do is figure out, what they've been trying to do is figure out a way to have a pricing metric that makes sense based on the business case. So poll question number 3 is basically similar to the poll question number 2 in terms of what factors would your organization want to evaluate if you're going to look at a federation solution? And I guess one of the questions I probably should have put in here as one of the poll questions was how much volume, what is the volume of data that you're going to be looking at? And probably also, are you looking at data in place, or are you looking at streaming data?
Sounds like fodder for another presentation, Kim.
Oh, oh, that's all I will say.
So we're looking at about 3-to-1, all of the above versus ease of use, which I think is very interesting. Ease of use is so important these days, where you're trying to integrate something. I certainly cop to that. All of the above, yeah, all of the above is now 4-to-1. So,
wow. Okay,
the data source is supported, the cost, and the ease of use.
Yep. So I think for everyone, I hope everyone sort of the takeaway from this is that, yes, there are a lot of different factors that need to be evaluated when you're looking at any of these sorts of solutions. But it is important to prioritize what your success criteria are, and to make sure that you communicate that with your vendor, because I mean, I think one of my favorite stories, sales stories of Frank's, is going out of a sales meeting at a huge federal agency where he was with an IBM seller who had been leading a presentation, and when they were walking out to the car after the presentation, the IBM seller turned to Frank and said, "We can do all that, can't we?" And Frank said, "Well, of course we can." But, the thing is, you need to be able to do what you need to be able to do, but you also need to be able to do it cost effectively, and it needs to be something that you can support and scale. So the next steps, we have some next steps on this slide, and we certainly invite you to get in touch with me or with Frank. I've got some contact information at the end of this. We are also, Frank and I are blog frequently, and we're pretty easy to reach. We'd be more than happy to answer any questions that you have, help you if you're going through some evaluation of some of these solutions, certainly help you get some pricing, help you get some technical validation. If you want to do a POC, give us a buzz. We can help you get it set up. And I think that is just about it. I really appreciate it. We're a couple minutes over. I appreciate everyone's patience. Our many thanks to our friends in Redmond who want us to refresh PowerPoint this morning. That was really good timing. And Frank, you did a wonderful job. I hope everyone appreciated it. Thanks so much. Take care.
Well, thanks for putting this together, Kim. You did a great job.
Okay. Well, thank you.
Bye-bye.
Okay, I'm going to log off the recording right now. Thanks, everyone.